This is a brief video showing some improvements to my matrix display project. Before talking about improvements, a brief summary of what the project is. You are looking at a Hub 75 LED panel consisting of a 64 by 32 LED matrix on a 4mm pitch. Driving the panel is a Pi Pico W with an FPGA loaded with a custom design. The Pico gets the information it shows via MQTT, which is ultimately loaded with data from a Home Assistant setup. More details are in my earlier video, which I'll link in this video's description. Hopefully it goes without saying that any flickering you see is an artifact of the camera in my phone and that the image looks great to the human eye. Anyway, back to the improvements. I now have two matrix displays in my house. I've been busy and have ported the code to run on ESP32 boards. Specifically, the board used with this matrix display is an Adafruit MatrixPortal S3. The same codebase can build for panels built around Pico Ws, Pico 2Ws and ESP32S3s. For Pico boards that don't have the companion FPGA used with my board, Pio mode is used. For improvements in either the Pico SDK or the FreeRTOS integration, it seems perfectly possible to achieve a flicker-free image now without resorting to an FPGA. Which is great, though it also makes me a little sad as my FPGA implementation of a Hub 75 controller is sort of obsolete. For the ESP32S3 bit banging is used. No clever coding is required to display a flicker-free 24-bit image using the otherwise idle second core. Here is the back of the display. There's not much to it really, just a Hub 75 panel, MatrixPortal S3 and a BME 680 sensor board, which is cunningly attached with Bluetooth. The sensor board returns values for temperature, humidity and air pressure, but of course this board is optional. Back to my original Pico W based board to demonstrate some other improvements. The first is that smooth transitions are now used when swapping to the next screen, whereas before it was a fairly jarring jump between the screens. A small but I think important improvement. Notifications are now either of normal importance or at a critical level. I did this because I use pushover for phone notifications, and that has a pretty cool critical level for its notifications where the phone can make a different, more jarring noise and the notifications will repeat until dismissed. Here the notifications flash red and repeat 3 times, as you can see. The system now gets the time from SNTP instead of using a real-time clock IC. This was done for the ESP32 port, but I made it so all boards work the same way. So on this Pico-based display with my custom mainboard, both the FPGA and the real-time clock IC are essentially redundant. I suppose that's progress. I won't bother to demonstrate it, but the panel now scrolls messages across as it boots, showing progress with connecting to Wi-Fi, getting the time from SNTP and connecting to MQTT. Lastly, and just for fun really, I added a parser for RTTTL ringtone files. You can now instruct the panel to play 1990s era Nokia ringtones, at least if you have a Pico panel. I haven't yet implemented this for the ESP32. Porting to arbitrary Pico or ESP32 boards, including self-designs and builds, should be pretty easy. The software only relies on the particular MCU family SDKs and makes no use of Arduino code. All the code details, links to blog posts, etc. is in the description. Thanks for watching and have a great day.